I'm one of the blockchain skeptics. As far as I can tell, most of the blockchain applications that get all the press are complete lies. Anyway, I would turn this down if I could. Something's not working here. All right. That's working anyway. All right. So I would like to, that's good enough. Okay. Anyway. Oh, that's right. I remember this. The volume I control up here that is going through the other cable. All right. And so we're here. I got to wait 10 minutes. Let's see if there's any other fun news.
Well, that is a blockchain application that.
Oh, well, that is what?
A blockchain application.
Well, the main one was the DAO. The original point of Ethereum was to host the DAO. That was going to be its primary application to show that it was valuable. And that was a investment platform that ran decentralized. And as soon as they launched it, it totally got hacked and all the money got stolen because it was not secure. So the next one that came out with CryptoKitties, which was a game. And as soon as it got popular, the blockchain froze, so you couldn't send any transactions because it can't handle enough transactions. And that is still like the #4 most popular application on Ethereum, and it's fallen to like 1% of its previous volume. So I think pretty much after CryptoKitties crashed, everyone kind of admitted that Ethereum is not a platform on which you can actually get anything done. And everything went back, well, you can make a proof of concept, and you can run it to a small group of people in a beta test to get investors, and then when they actually invest and you try to scale, it will just collapse and can't handle it. So now they're all trying to develop something like a Lightning Network or something to make it run faster, and all those involve off-chain transactions, which is kind of, so I mean, I don't know what's going to come of it all, but that's where we're at. And there's a huge interest. There's an incredible steady number of blockchain believers. An enormous number of people believe that somehow it's going to revolutionize the world based on nothing I can understand. It's like Trump believers, like any other religion. It's an article of faith. The blockchain is somehow revolutionary, new, it's going to change everything. And exactly why, you're not supposed to ask, I think. But it's incredible how many people believe this. So we'll see if any of it's ever proven true. So far, it has no applications that have actually accomplished anything. The only one closest to it is Bitcoin. But I think it's highly debatable if Bitcoin has actually accomplished anything you weren't already getting done with Visa and MasterCard. But maybe ransomware. But even then, but an incredible number of people believe that something awesome is going to come out of these public blockchains. And I don't know. But private blockchains, like Hyperledger, have a clear application, and that's growing for a sensible reason. There are actual business cases for that. That's going to happen. That's already happened. That's what's going to, but that's not, these public cryptocurrency projects, though, are like a political theater. And like most giant political movements, it's very debatable whether they're accomplishing anything or not, like wars, like the American War of Independence. I'm very skeptical that it accomplished anything either. So big political movements rely more on faith than actual accomplishment. And they have a lot of faith in the Bitcoin community, in the cryptocurrency community. A lot of money and a lot of faith. And they don't seem to be in any way inhibited by lack of real accomplishment. See if anything else is fun here. There was a fun thing from Trump's cybersecurity chief, the previous New York mayor, Giuliani. He tweeted a link and he made a typo in the URL. So it went to a non-existent domain. So somebody bought the domain and put up a response, put up a page insulting Trump. And he screamed and yelled that Twitter let him get hacked and someone changed his tweet because he doesn't understand what URLs are and how the internet works. And he's been a cybersecurity chief. It's kind of hilarious. He's still screaming and yelling that Twitter let him get hacked. And that was the hack. No, nothing was hacked at all. He put up a typo, but he doesn't understand that. There was a good talk I saw a couple of years ago at a convention where this guy made typo squatting domains, like misspelling company names, and bought them. And he was able to get terabytes of confidential proprietary company email because everybody in their email list has a certain number of their emails are misspelled. And so copies of these internal documents are going to these other domains and mostly going nowhere. But if you buy those domains and put up email servers, you can receive this stuff. And that's what he did. Anyway, Anything else fun? Microsoft is abandoning Edge. They had Internet Explorer, then they dumped it to make Edge. Now they're abandoning Edge, and they're going to go to the same internal engine that runs Chrome and Firefox. So they've sort of given up being a rebel there. I saw they're also abandoning ReFS. They moved to NTFS in 1993, and they kept promising another file system, and they finally brought out the redundant file system, and they're abandoning it. So there'll be nothing there. And I think, well, I'm supposed to wait another few minutes before going. See if anything else exciting. I mentioned before that Kubernetes has a serious flaw, but there's no actual exploit out for it. And the patches are out now. Kubernetes is a security orchestration suite. If you use the cloud, it's not enough to have one machine. You have to have thousands, and you have to have some central repository controlling them all. And Kubernetes is one of the big products used for that. So if you use the Amazon cloud, you have a Kubernetes machine to distribute them all. And it turns out that it's got a severe security flaw. There's a way to get root and to hack into it. So you have to update to the latest version. There's no exploit out, but it sounds very simple. Something about the TLS key from one session can just be used for another session, and you become treated as root even though you're not root. I might be mixing up with another one. It was very simple. Anything else fun? Yeah, all seems kind of boring. These chip cards in America are being compromised because merchants are using them in the mag strike mode. So the fact that it's a chip card doesn't help in that case. Marriott got hacked, 500 million accounts stolen, and it's been going on for 4 years, now they tell us. Now they're trying to say the Chinese did it. I guess that's possible. And Australia passed a law for backdooring the encryption. So we'll see what comes of that. Many people want to do that in America, and it hasn't happened yet. Although I think it definitely will happen pretty soon. Some form of law enforcement access to encryption, I think, is definitely coming. But I don't have any insider information about that. Anyway, I think we're close enough to the official time here. Because of the fire, we're somewhat behind in this class. So let me point out some things. I've got a wireless chapter and an encryption chapter. The encryption stuff is quite important. We'll only do a little bit of it tonight, but if you want more encryption, there's a whole encryption class coming, which I highly recommend. This is very good stuff, and we got blockchains in here too. But this is very good encryption. It's a very good book, and this is where we're going to go through it in all detail. So I highly recommend it. I've been doing this at all the cons in a CTF format and everything. Encryption is really important, and people really need to learn how to do it right. It is spectacularly stupid how most people implement encryption. They don't even know what they're doing. And it is not that hard to just learn how to implement encryption correctly. That class is not really into math or the proofs or anything. It's just learning how to use it correctly. That's all we are as engineers.
How often is that offered?
Only every 2 or 3 semesters. A little bit more now that we're getting more security teachers. I'm able to do it more often. But not every semester. All right, let's see if I can get my wireless stuff up. There it is. All right. All right, and we'll do some of this and a little bit of the encryption chapter, and that'll be the end of this. This is the last class meeting. All right, might as well get the Kahoots ready. All right, so let's talk about this wireless stuff. So we'll talk about how wireless technology works, and we're all, of course, familiar with the fact that everything has become wireless. A lot of things go over the cell phone network, but the other things mostly go through the public access band, 2.4 gigahertz. So you have an access point, and then you have an interface card on your device, like your computer, and then it goes to a cable, typically Ethernet. So your access point just converts a wireless network to a wired network. And as soon as they started selling these in the late 90s, consumers rebelled and said, that can't be safe. My data is just going everywhere. So they were quite correct about that. So the access point broadcasts an SSID, a name like Cisco or something, every several times per second, like 10 times per second typically. It sends that out. And that's the service set identifier. Every device within range is all just shouting over each other. There's a ton of interference. So the only way it can tell which network you're trying to talk to is it looks at that SSID. And all the other devices talking on other networks in the same room, it can pick up all that traffic too. So it's kind of nuts. So broadcast the SSID. If it does, which is normal, then it will appear on a list like this in your computer, and you can choose it off the list. You can change the SSID. If you don't, it's typically some default which tells people what brand your device is, which might sound harmless, but it's not harmless at all because wireless routers are incredibly insecure. They're typically running very old, out-of-date versions of Linux that never get patched with trivial, obvious security flaws. And if you know which model it is, you can just download an exploit that gets you right in. So concealing it would be somewhat good, although it's not hard to tell what it is from the MAC address anyway, but at least changing the name of the SSID will stop the weaker attackers. All right, so changing your default SSID is a recommended security practice. It's not a very strong security measure, but it helps to make it stop a certain kind of attacker that doesn't know much. So they each have their own proprietary configuration screen, which is different on each one, but they're all just giving you the same settings. You can change the MAC address, you can change the way network address translation works, and you can choose some kind of encryption mode. For a long time, they were defaulted to no encryption or WEP. Now all of them, all the modern ones for the last 5 years, all default to WPA or WPA2, which is much safer. WEP was the original standard approved by the IEEE. It was fantastically poorly designed with ridiculous flaws, so people can just sail right in without knowing the key. So it absolutely failed to do what it says, make you as safe as you would have been on a wired network. And so WPA was an emergency patch put in by manufacturers without the approval of the IEEE, because the IEEE was very slow at approving WEP. So the manufacturers made a temporary improvement of WEP that just patched the specific flaws that were being exploited and which could run on old hardware with just a firmware upgrade. That was the point of it. WPA is just WEP, but it changes the key for every packet. And that turns out to be enough to stop the attacks from working, and it's really quite safe. But WPA2 is the new completely rewritten protocol. It needs newer hardware. These days, any hardware newer than 10 years can do it, and is actually using superior cryptography instead of just bad cryptography with new patches on it, which is what WPA is. But in fact, there was never any significant break into WPA. WPA is fine, and WPA2 are both fine. So anyway, they say you can turn off the broadcast. That's another really weak security measure, but it means random people won't see you on the list. It does not hide anybody that knows what they're doing because every packet has to have the SSID in it. So you can just run Wireshark and sniff and see the SSID, but it does mean you're not just sitting there in the list. All right, everybody has to have a NIC built into your laptops to send and receive wireless traffic. And this is all defined by the IEEE. The general way all technology works is the IEEE is a volunteer committee of people coming from industry, and they lobby for standards to be given the blessing of the IEEE. So after something has been around and somebody is a market leader, they can pressure and that now becomes the standard. But anything new is always breaking the standard. So your very newest devices from companies like Cisco often are off standard, and you can only use it if you buy all Cisco gear. And then it becomes a standard. Once it's a standard, everybody makes multiple devices from multiple vendors that obey the standard. So, but the cutting edge is always ahead of the standard. This is why it's kind of nuts. Standards come around behind, and sometimes there are market leaders like Microsoft. Until about 2002, Microsoft was just charging ahead with the Internet Explorer. They owned 99% of the desktop, so they just completely ignored the IEEE and put non-standard stuff in IE all the time and said, we are the standard, whatever you do, that's the standard, broke everything, and everybody just had to write to Microsoft's rules, and the IEEE was just wandering around behind yelling and screaming and being ignored. Then Microsoft lost their dominance through failure to innovate, which is what everyone threatened them with, and now the Microsoft is obeying standards and even going to WebKit, like other people, realizing that they no longer rule and they just have to obey the rules that everybody else is playing by. So that's the IEEE. Various groups here work, and they define the standards for networking. Originally, 802.11 was the first wireless network that only ran at 2 megabits per second. And the main thing this did was handle collisions. If you remember your 106, your Net Plus, there was once a network standard called token ring. Token ring was a logical, intelligent standard. You would have a token that went around the network, and every device would get a chance to put some data on the token. And you cannot talk until the token comes, and when somebody's using it, you have to wait until they're done with it. So one piece of data is moving around at a time. And Token Ring ran at 4 megabits per second and 16 megabits per second, and you could move that amount of data through a network, and there was no argument about colliding or anything. Then Ethernet came. Token Ring devices were expensive. The NICs were expensive, and the hubs were expensive because they had to do this negotiation of figuring out who's talking. Ethernet was the alternative. Just let everybody talk all at once and collide with each other and destroy each other's data, and then detect when that happens and retransmit it. It's totally sloppy, and it turned out to be much cheaper and actually run much faster. But because it's so sloppy, if you ran an Ethernet network at 10 megabits per second, you could only use about 2 megabits per second before the collisions froze it. If you have 100 megabits, you can only get to about 20 or 25% before it freezes. So it's very sloppy and doesn't really run anything like the rated speed, but the end result is, in practice, it's much faster. So doing something sloppy and fast turned out to be the winner. And so that's the issue here. Now you have this issue of collisions in Ethernet. So when you make wireless Ethernet, you've got another problem. The way collisions are detected in a wired network is you have a signal of voltage coming from the NIC, and it goes to a cable at the other end, and the voltage does not fall by any appreciable amount. So if the voltage, in the simplest conceptual model, you might imagine that 0 volts is a 0 and 5 volts is a 1. Although in fact it's done with a more complicated standard these days. But the point is, if you consider the voltage of 10 volts, if two packets collide, you get a 5 plus a 5 and hit a 10. And a 10 could never happen from one packet. That's how collisions are detected. If you deviate from the allowed voltage range by too much, it knows there was a collision. You can't do that in wireless networks because wireless signals fall with the inverse square of the distance. So if you're close to the device, there's a huge signal. If you're far away, there's a very small signal. So there is no forbidden voltage range. So you cannot detect a collision. When wireless packets hit each other, they just garble each other, and there's no way to know that's happened. So this makes wireless networks much less efficient. They cannot handle collisions, so instead they use collision avoidance. Before your device talks, it sends a clear to send message. Everybody shut up, I'm about to talk. Then it waits. When everybody shuts up, it talks. Then it says, did you get it? The other guy says, I got it. It says, okay, now you can talk. This goes on every time. So less than half of the actual bits per second can actually be used to transmit data on a wireless network. Most of the bandwidth is spent arguing about who's going to talk next. And still, there are some garbled packets that have to be resent, quite a lot. If you go to a busy coffee house, you can see them in Wireshark, all these black frames zipping by of all the ones that got damaged in transit. But yeah.
So the actual data throughput is like 50% or like
yes,
20%?
At the very best, 50%. Like if it says 54 megabits per second, you're really lucky if you can get half of that actual throughput. Often much less, often more like 10% of that. Yeah.
Piggybacking off his question, does that same thing go for LAN connections too, or no?
Well, for Ethernet? Yeah, Ethernet, you typically can get up to about 20% of the speed before it stops working in a normal network. However, if only one device is talking, you can run it right at the full speed. Because it's collisions that limit it. So if there's only one device talking, like you're downloading something late at night, then you get the full speed. You have a whole room of people all sharing one device, then they collide, although in these days it's mostly switched, which lowers the number of collisions.
Yeah,
so it's closer to each one of you having your own channel.
So there's no collision between me and switch because I'm the only device.
Well, there'd be almost no collision. The problem is there are broadcasts. There's actually quite a few broadcasts. So yeah, but that's right. In general, the switch networks, Ethernet gets better, but it's still never as good as Token Ring. Token Ring actually delivered data without any nonsense, but that turned out to be too expensive. Yeah.
As let's say you got Comcast modem.
Yeah.
You got your let's say you got a high-end dual band ASUS router,
yeah.
an AC standard router hooked up to it. You got 4 LAN devices, but no wireless. Does that still cause collision or not? If all those 4 devices requesting access.
If you have 4 devices sharing a switch network, there are probably no collisions that matter, not for any significant amount. Just a little bit of the arcs, which is not enough to matter, I would think. I haven't actually tested it, but that's my understanding of it in principle. These are good questions. Anyway, so you have to have an addressing. So you call these things in wireless LANs, you call the addressable unit a station. And your station connects to an access point, and you call that a basic service set, which is all the devices in one room connected to one access point. The reason you call it that is because, now if you're a home network, this is probably all you have, is one basic service set, one router, and devices connected to that one router. But if you're a larger company like City College, there are hundreds, I think now 450 access points all over campus, all in one giant LAN. So you have a distribution system in the middle, which is Ethernet. In this case, it's fiber Ethernet we're using. And so each room has its own access point, and then they're connected by wires in between, and it's all the same wireless network. So you can pick up your laptop and carry it down the hall from one room to another. And because of the beacons, it will know this one is louder, I'll talk to this one. And then as I move down the hall, this one will get weaker and weaker, and the other one will get stronger. It'll notice when this one is stronger and silently let go of this one and associate with that one. You could have a download in progress, and it would just keep going. The same way your cell phone does. If you get on BART and go from one station to another, your cell phone will just let go of one tower and negotiate and connect to the next tower without hanging up on you. And so that works if you leave the beacons on. That's why turning off beacons is a really bad idea in a large WLAN. It fouls up the roaming, but that's how it works.
Do they have to all be on the same subnet?
Yes. They would all have to be on, I guess, do I know? I guess I don't know. Maybe they could be on different IP addresses. I would think that would break things, but I'm not sure. That's a good question.
Same subnet.
In our network, they all are. They all are on the same subnet.
Yeah, if it's the same subnet or same virtual LAN, it's easier.
I would think if they're on different subnets, it would break your connection. Well, you do, but the server would have to send to a different address. Yeah, I'm not quite, it's a good question. I don't know the answer. I know in IPv6, there's a mobile version that tries to handle that. In IPv4, I'm not sure what happens. Anyway, another problem with the low band 2.4 gigahertz is that the channels are too close together so that they overlap like crazy. And there's really only 3 non-overlapping bands, and that non-overlapping is at the 50% power. So that's not very non-overlapping. So even though there are 11 channels, they overlap so badly, you can really only use 1, 6, and 11 in most circumstances, which is kind of insane. So this is why it's a lot better to move up to 5 gigahertz, where there really are something like 100 non-overlapping channels. And that's why everyone did pretty much. I think most modern devices are moving up to 5 gigahertz, and some of them even higher. So there's also infrared, which has been around for a long time for various devices. The problem with infrared is that you have to have line of sight. So you have to point the device in the right direction. So it's not that common for data transfer. So 802.11a is where it all started at 5 gigahertz and at 54 megabits per second, relatively short range, and it never made it in the marketplace. Nobody cared. What really hit was 802.11b, which is slower, maximum speed of 11 megabits per second, of which you'll only get a small percentage. But at this time, everybody had 56K dial-up for the internet connection anyway. So even getting a small fraction of 11 megs is enough. And this is where they introduced WEP, Wired Encryption Privacy, to try to trick consumers into feeling like they were safe when in fact they were not safe at all. WEP was cracked immediately. It was a marketing ploy essentially, just thrown together sloppily and ridiculously easy to crack. So then some other standards came out up to 802.11g, which was faster, but still in the 2.4 gigahertz wavelength range, which meant it had all the interference from the other devices. The reason why that band is used all the time is because it's one of the few bands that is not reserved for telephone and for television and other channels. There's only certain small regions of the spectrum that are available for unrestricted consumer access, and 2.4 gigahertz and 5 gigahertz are among them. Anyway, 802.11i introduced WPA, which is the Band-Aid put on WEP that runs WEP with the key changing more often to stop the WEP attack, because the WEP attack requires you to get 50,000 packets and you introduce the key from the packets. And so you change the key with every packet and that attack won't work anymore, and that turned out to be enough. Anyway, 802.11n was the new hotness in 2009 to get us up to 600 megabits per second by having multiple streams, each running at 54 and bouncing them off the wall and the floor and different spatial channels with multiple antennas at the NIC and the router. And this is building after DSL. DSL modems are amazing. DSL modems take a wave and they encode data in every bit of the wave, the frequency, the phase, the amplitude. They take every possible modulation and they test to see how much noise there is in each degree of freedom and encode data in everything they can possibly find. That's how they get fast. And this does the same kind of thing in spatial resolution. It takes the relative signal among the different antennas and deduces where it can cram more data in. Really quite complicated. Yeah.
Literally sends one channel this way.
Yes.
But it's very directional. Same channel going back that way.
That's right.
So people in the same room.
That's right.
Each other on the same channel, but they're not.
Multiple spatial channels. It's on the same wavelength. It sends data this way and that way and that way and untangles it with the multiple antennas. kind of madness. But it can be quite fast. You have to have these devices with multiple antennas for you to get the full benefit of it, though. Yeah.
Is that like MIMO?
MIMO, I think so. MIMO is multiple input, multiple output. I think that's the general technology. Yeah. Anyway, AC is the next step. Even wider bands, more spatial channels. These are now for sale. AC goes up to 1,200 gigabits, supposedly. Not 1,200 gigabits, 1,200 megabits. This one here said it would go up to almost a gigabit, 866 megabits per second. The standard goes above 600, 802.11 AC. And on the MacBook Air has had it for a while. And AD is the next one, wide gig. It's supposed to go to 7 gigabits per second, but it's considered very short range, so no one has really suggested it for normal computer networking. What they're planning to do is use it to replace the cables in your house. So your TV and your modem and your keyboard and everything will all be connected by this. That's the idea. I haven't heard too many people doing it for that, though, AD, but in principle, it'd make a clean desk again. And 802, the iPhone supposedly has it. I guess my phone supposedly has it. I haven't tested it anywhere. It would be interesting to see. Right, then there's European standard Hyperland 2, which is different for no good reason. And then there are other standards, like 802.15 is short range, and it's used for Bluetooth and a few other similar devices. Bluetooth is the main one we see. For short range on your body. They call that the personal area network, things attached to your body. Bluetooth originally was unencrypted and only went at 2 megabits per second, but now it's up to 24 megabits per second, and it does support encryption, but most consumer devices have it effectively turned off because the code is set to 0000 and you can never change it. So devices like this are typically unencrypted. And there's a fun Joshua Wright video that shows him standing outside Starbucks, breaking into other people's phone calls, talking and listening to them. Because if they're using this, you're sending your phone through unencrypted radio, and anybody can just read and break into it. Why? It's fantastically illegal to do. So he said what he showed you there was just a simulation. Because even though it is technically trivial, it is the phone wiretap laws are incredibly ruthless. So you can buy a $20 USB radio, software-defined radio, plug it in your machine. You can use Wireshark to sniff on phone signals and see them. And they showed us how to do it at DEF CON, and they said it's all completely illegal, so I can't assign it for homework, but it is technically very easy to do. Now, that's only going to work for the older standard. The new standard has encryption on it that's very hard to break, 64-bit encryption. But there's a downgrade attack. You can put up your own cell phone tower, and you can say downgrade it to the old standard where the encryption is missing or very weak, and then you can intercept phone calls, and phones will typically connect through the old standard, so you must have traveled to a country with an old standard without telling you. And that's happening all the time. You can put an app on your Android cell phone to detect rogue access points, and people tell me you'll see them almost everywhere. So the cops are doing it all the time. They drive vans around, they park it in a neighborhood and intercept all the phone calls and man in the middle of them for like 2 blocks around because there's somebody they're wiretapping, and any hacker can do it any time. We got some of the equipment to do it here, not quite all of it. We're going to set one up here and test it under some controlled conditions, but they're missing some pieces. We haven't done it yet, but it is actually not that hard to do. It's just, like you say, fantastically illegal if you actually wiretap somebody's phone call. At DEF CON, they set up, there's a ninja party at DEF CON, which is super elite, and they always have a special group of people. So about 3 years ago, they gave everyone a cell phone, and they put up their own phone network just for the people who are in the ninja party. You can totally do that, technically, although in practice, the legal situation is pretty touchy. All right, the WiMAX is a standard to put wireless on the whole city, and this was pretty hot, and Sprint rolled it out over the whole nation and then rolled it back. WiMAX was kind of a swindle. It wasn't really fast enough. And there's 802.20 for try to reach people in trains. WiMAX was rolled out and then rolled back and abandoned in 2016. I actually had a WiMAX phone. It was fast for like 2 months and then went back to slow because the WiMAX network appeared and then they rolled it back. What replaced it was LTE. LTE is much faster, and that became the long one. It is an acronym that means absolutely nothing. It means long-term evolution, which tells you nothing about the technology. But in fact, it's the one that took over, and it's the new hotness for networks. So there's a chart of them comparing them. See, most of the wireless standards that we use for data are 2.4 gigahertz, but a few of them go to 5 gigahertz, which is a much better place to be because there really are enough non-overlapping channels that your packets aren't constantly being nuked by everybody else's packets. Yeah.
It was like, I think like 5 years ago, when it was a long time ago, Like every time my wife would put something in the microwave,
Right.
I'd be booted off the internet.
Yes, yes.
Because like I'd be sitting there like on the kitchen counter with my laptop, and the microwave was literally right there.
Yeah, microwaves create, these are microwave ranges. So your microwave does interfere, absolutely. And noisy electric motors will interfere. You know, it's the big problem with all these standards is wireless interference. Anyway, let's try some Cahoots. I've got them here. And there we go. And should be some, oh good, it sounds like there's going to be some glorious Kahoot music. Yeah, there it is. All right. Now get a document open to record the winners. The Christmas version, yeah, they added some bells or something to it. All right.
Especially because the normal music, it has a little bit of the original music.
Yep, yep. Yeah, they customized the music. All right. I'll give it a few more seconds. Here. All right, let's see what happens here. All right, so the name of the network. All right, the service set identifier. Which one goes at 11 megs? Okay, 802.11b, the first one to hit the marketplace. Which one goes at 7,000 megs? That's AD, the new hotness. All right, which one goes at 10 meters? A distance of 10 meters. Yeah, it's Bluetooth, that's the point. It's only for short range. All right, and which one has been abandoned? Climax came and went. All right. So it's Peter, D, and Abdul, and Becky, or BCK. All right. Hopefully those look like more or less real names. If somebody has a name greatly different than that, they'll have to inform me or they ain't going to get their points. Anyway, all right. So we went and looked in the wireless network here. This is why, like I said, Microsoft once owned the desktop and they could do anything they wanted, and they slipped because of their failure to go on mobile devices, which Ballmer knew, and this is why he started throwing chairs around. They knew that these big, heavy, square boxes sitting on your desktop are dinosaurs, and all the future is cell phones and tablets and portable skinny laptops, and Microsoft failed to get there, and they have become irrelevant. And this is for 2013, which is getting to be a while ago, But notice number one is the iPhone, then Android, then Mac, then the iPad. All Windows devices are down below 10%. They're just in the change. But, oh, I'm sure it's down even lower now because, and
2 years ago, like mid-single digits.
yeah, and you notice something else. Linux won. All of these are Unix and Linux. Unix totally won, replaced Windows, but what didn't win was free Unix. These are proprietary Unixes people pay for. Although technically the software is free for Android, but not that much. Actually, Microsoft owns a bit of Android. They get royalties in every Android phone that sells, which is where they actually get their money because Windows phones don't sell at all. And I think they abandoned them again. They have several generations of stupid Windows phones that nobody bought, which they abandoned. But they just can't make it onto cell phones. And anyway, that's where we're at. So you can monitor this stuff, and if you turn on Wireshark, you can monitor. I don't think I'll bother doing it live, but you can see the raw frames, and you'll see what a mesh wireless is. Anyway, in wireless technology, you have a new problem. You don't have a cable, you don't have a port, you don't even know where the physical device is. So how do you know people are allowed to be on there? You now have to figure out who they are. So there are protocols for this. 802.1x is the standard to authenticate devices. And it has many different versions. One simple version just reads the MAC address and only lets a certain MAC address do. That's not very secure at all, but that's called sticky ports in the Cisco implementation. One version of that. And here's some protocols used for it. Point-to-point protocol is what ISPs used a long time ago to just let in dial-up users. It's only intended to do one-to-one, one end of the cable, and the original version just sent passwords unencrypted down the wire because it's not supposed to be a shared network. It's just supposed to be a cable with you at one end and the ISP at the other, so there's no need to encrypt anything. That was the plan. Obviously, PAP is subject to sniffing and replay. So they moved up to CHAP. This is where you have a challenge. The server sends you some letters. You add the letters to your password and hash it with something like MD5 and then send it up. And now the thing that goes over the wire is not equal to your password. However, it can just be replayed. And if you're using old protocols, it's not that hard to crack, but it is better than just sending plain text passwords over the wire. EAP is the enhancement. EAP lets you choose any of a variety of authentication methods, and some of them are really quite secure, like digital certificates. The same kind of certificates you use to identify websites like Google on the web, you can have a certificate attached to the user, and they authenticate with that. Kerberos is the MIT system, which has a complicated system of exchanges and a ticket server, and you get a ticket, which is like a ticket to a movie. It gives you the ability to connect to one server and be trusted for 10 hours, and then you need another ticket. And you do all that by trading something around that's a hash value that's related to your password, but only in an indirect way. That's the MIT system, which is what Windows domains use. So an X509 certificate is what identifies you if you use certificate-based authentication, and it's what web servers use to identify themselves. That's the standard X509. So you can see it here. You can open it in your browser. It has the name of the company. It has the domain name, and then the real name of the company, then the name of the company that issued it, and then various fingerprints and serial numbers, which are used to authenticate the certificate. So when I try to connect to Google, at this time, Google used a Thought certificate. Now they are their own certificate authority. And so it tells you Thought, which, by the way, is the guy that made Ubuntu Linux. This was Mark Shuttleworth. He made Thought, one of the main certificate authorities. He made $100 million. He sold the certificate authority, and then he funded Ubuntu Linux and trips on rocket ships with him and stuff. One of the big millionaires funding all this stuff. But mainly Ubuntu Linux is the main thing we notice. Anyway, so when you connect to Google, you get the certificate. Then you send the certificate up to Thought to see if it's really valid. And your browser has built into it identification of Thought, so you know who they are. And when Thought says it's really okay, I really sold the certificate with this fingerprint to those guys, then you're in the business. Notice that this was an MD5 and a SHA-1 fingerprint. And until about 2008, the main certificate authorities just used MD5. And that was known to be unsafe. And finally, at DEF CON, hackers made a fake RSA certificate authority that could take fake certificates and fool people by cracking MD5. And that embarrassed them enough that they upgraded to SHA-1. Now SHA-1 is no longer considered safe because Google cracked it, and so everyone's pretty much using SHA-2 now. Anyway, so your browser gets the public key. The public key is in the certificate. Here's one. This is from a few years ago, so it was 1120 bits. But that's a long public key. You scramble your data with that public key, and nobody on earth can read it except the company with the private key, and that's the people that own the certificate. That's the point of it. lightweight. Now, it turned out when, yeah, go ahead.
One of the classes you had mentioned something that, like they reuse random numbers, or they reuse keys, or
Well, everybody uses
are
this.
more frequent than others.
Yes, there are various defects. Now, one thing that is not a defect is the fact that everybody uses the same key. If you put up a certificate like Google, you have a private key and public key pair. All the millions of people using Google all get the same encryption key.
The same public.
The same public key, and they all open with the same private key. But see, private key encryption, or public key encryption, this works because you never tell anybody the private key. So the system is you have a secret and you never tell anybody. Now that's a good system. The older kind of encryption is shared secrets, where I have a secret, but I have to tell somebody, and that is fundamentally an oxymoron. You have a secret, but you told somebody, well, then it's not a secret anymore, because how do you know the person you gave it to didn't tell somebody else? And the answer is, you don't know that. It's like these locks. They give me a metal key. How did they know I didn't make another copy of that key? They don't. So it's a weak security measure. They're riding on a shared secret. But this relies on a non-shared secret, so it's fundamentally logically more unbreakable. However, the math is more messed up and vulnerable.
So as long as the key is truly random.
His key is truly unpredictable, and as long as there's no way to find the private key from the public key, because they are mathematically related. That's right. That's it. All relies on the difficulty of that problem, and that is not a mathematically perfect statement that that problem is difficult. That is just a statement of current practices. And you cannot be sure that there isn't some way to solve that difficult problem that you don't know. So you're not really secure. That's the disturbing part. All you can say is, in practice, we believe that nobody can find the private key from the public key. Anyway, so when WEP came out, WEP was the standard. Everybody was moving to wireless networks, but WEP wasn't secure enough. And because the IEEE was really late in coming up with an official improvement, everybody invented their own proprietary ways to improve on WEP. So Cisco invented LEAP, Lightweight Extensible Encryption Protocol, Authentication Protocol, which was supposed to be better than WEP, but it turned out to be vulnerable. And Joshua Wright wrote ASLEEP, a hacking tool. And I think it's in your projects here. You use it to hack into a VPN. This was some of the early days of vulnerability disclosure. It's getting a little better, but at this time, anybody that revealed a vulnerability was dumped on, and here's what Cisco had to say. Somebody that actually made a theoretical threat real is just a jerk. Why do people do this? He just wasted millions of dollars of infrastructure. So this is an interesting attitude, and this was the standard attitude of all the security companies, all the companies that manufacture stuff at this time. We made broken junk. We lied to customers and sold them this junk. And the hacker that revealed the problem is the one that made that stuff worthless. It was perfectly fine until this idiot told them there was a problem. As long as nobody says the emperor has no clothes, we're all making money and everything is fine. It's the ethical hacker that put out the product demonstrating the flaw is the one that ruined it. We were all having a good time until then. This was a very common attitude at the time. It's changing, I think, now. An increasing number of people are admitting that when someone comes to you and says you have a security problem, you don't just punch them in the face and tell them to shut up, but in fact, listening to them and fixing the product is probably a better plan. Yeah.
So this is the equivalent of getting mad at your oncologist because he told you that you have leukemia.
Absolutely. You're shooting the messenger.
Would have been happy.
I know, but this is the way it's always been. You know, someone comes and tells you you have a big problem in, like, the Catholic Church. Your priests are doing really bad things. You say, oh, just shoot this guy and we'll keep going. Pay them off and we'll keep going. This is the natural response of any authority figure, is just sweep this under the rug and hope I'll be gone before someone finds out. But eventually you can't keep sweeping it under the rug, and you have to actually fix the problem. Well, we're all doing it now with climate change. And I just heard an article on NPR yesterday. It was amazing. San Diego, a town near San Diego has all this expensive property right on the coast. The sea level's already rising. It's all going to flood. So there's a federal plan called Planned Retreat, where you start moving the houses and abandoning land. They said, no, you can't even talk about that. There'll be no talk of that, because as soon as you talk about how we're considering planned retreat, my property value falls. We all know that my property is going to flood in 50 years and be worthless, but we're going to not talk about it so I can keep my property house value up. And that was the official decision the government took. Well, it's interesting to see what happens to stakeholders. So here's another one. Verizon had one, and so they labeled these guys narcissistic vulnerability pimps for publishing a proof of concept tool revealing a Verizon security flaw. So these people went and got caps made that said narcissistic vulnerability pimp for more around, which I thought was a pretty good response. Anyway, so EAP has other methods like TLS, which uses certificates at both ends and is therefore quite secure, but this was considered impractical because certificates used to cost a lot of money, like $300 a year. Now the EFF in San Francisco has for several years been handing them out completely free, and that is so it's no longer a statement that they're expensive, but a lot of people don't use them. PEEP and Microsoft PEEP are considered pretty good and only have certificates at one end. There are many different versions of EAP, and some of them are quite secure. Anyway, 8021X is an overarching standard for authenticating things on a wireless network, and you can use it on a wired network too. And here's how it works. Somebody wants to join, they're the supplicant. They talk to an authenticator and somehow send them some credentials to prove that they're there. Those credentials go to an authentication server, which is often using Radius, a common system used for this. That's called a AAA server, Authentication, Accounting, and Auditing. And this has been around since the days of the wired telephone network. A AAA server was the server that determined whether you were actually a customer that had paid your bill, and then verified that with authentication, and then kept track of how many minutes you called so they could send you a bill later. That was the AAA service, and that's still happening here in your wireless networks. So the supplicant comes in, they say, I want to join the network. The authentic access provider doesn't let you on the network first. It says, well, first you've got to send me some credentials, like a certificate or a password or something, and then I'll go ask the Radius server that has the credential data store, is that a good credential? And if it is, then I'll let you on the network. All right, that's the game here. WEP, I mentioned before, WEP was the original wireless encryption system that turned out to be very vulnerable. We used to crack it for homework. I gave it up because WEP is essentially extinct. WPA was the improvement, which was only expected to last for a few years to let us use the WEP-enabled devices until they reached their end of life, and we all bought new hardware that was strong enough to do WPA2. But it turned out that the 4 patches put on here were in fact enough. There were not any more vulnerabilities found after the first 4, and it turned out to be fine. There's a thing called temporal key integrity protocol that keeps changing the key, and something called the message integrity check and extended initialization vector. These are the specific mathematical changes to break the existing WEP attacks. Yeah.
So it changes the key which every packet.
Yeah.
But then the keys must be related. Otherwise,
yes, and I don't quite know how that works. It's a good point. Somehow it's changing them. Yeah, I don't quite know what the pattern is.
So the cracking, you have to, I guess, understand the initial sequence, because once you get that, then there's got to be an algorithm that says this key follows this key follows this key. Otherwise,
you would think there has to be, and I never got into the details. But a lot of people were worried about that kind of thing, and they didn't expect WPA to last long. But in fact, it did. It turned out that the techniques they used in WPA were robust enough. They had all these various techniques to prevent the existing WEP attacks from working. And it also added 8021X to it that was available. So there are versions. WPA and WPA2 actually have a home version and an enterprise version. And the home version is where you have a shared secret. You type in your password on every device, and that is only valuable for home users. The enterprise version, you have to pay for a Radius server, and everybody has their own key, and you can change it. That's what you need at a company. Every employee has their own credentials, and now you can remove one employee's credentials because they quit without making everybody else change their password. It's like a domain controller. Everybody has their own individual account. That's more expensive because you actually have to have a server holding all those keys, so that's the enterprise version. The other one's called shared secret. The pre-shared key is the home version, where you have to type that in every device, and the 8021X system is with the authentication server, where you have to pay for a server, and now everybody has their own independent account, which is what you need at a company. There were some WPA attacks that were developed that let you do a few things you shouldn't be able to do, but it turned out these did not extend as far as they did in WEP, where you could actually get on. They were just sort of curiosities where you could break a few rules, but you couldn't really find the key. However, this all is kind of irrelevant because another standard was added around this time to all routers called WPS. Now, I read about this in the Microsoft literature. I was teaching Microsoft Windows tech support at this time, and the Microsoft literature said, this is a great security improvement because what it does is it generates a password, and then you don't have to remember the password and type it in every device. You have this system of automatically moving it over the network. You press a button on your router and a button on your laptop, and it sends the key over just once, and now you can, I said, this is great. The key can be a long random number that you couldn't remember. It'll be much safer. And that sounds good, but the problem is that's not what it does. What it does, you can type in a key as long as you want, and it will boil that key down to an 8-digit number. And the 8-digit number is not even 8 independent digits. It's a 4-digit number, and then another 4-digit number, and the last digit is a checksum. So the total number of possible values is only 10,500, which is not very many at all. So you can just try them all. And that's what this attack does, Reaver. It just tries every possible WPS key. So every device with WPS called Wi-Fi protected setup on completely undoes all the benefit of WPA and WPA2. And every device has had this since 2008. It's been a standard on every device practically. And so this is why some people like to put third-party firmware like OpenWRT on the router, because OpenWRT never supported WPS and they never put it in because they didn't jump on it when it was new. And by the time they might have considered it, people knew how terrible it was. And this is such an obvious attack that several manufacturers figured out all by themselves that this can't be right. And they put in their own non-standard proprietary defenses. Like after you get the WPS key wrong 10 times, it locks you out or something, which is not part of the original protocol. And that would slow down this attack. But anyway, in practice, this attack is not too powerful. I had to buy a $150 router to get it to work at all. It turns out there's another kind of defense called defense through terrible hardware. If you just start guessing the WPS key, your typical home router will just crash after about 10 or 20 guesses and have to be rebooted because it's just really poorly made. You have to get up to the $150 price range before any device will actually stay up long enough to run this attack. And so I was able to do it in 19 hours. I decided not to assign it for homework because that was not much fun. But anyway, so that's the game of that. Anyway, by the way, then you might think what you want to do is turn it off. But it turns out a lot of the firmware, in particular the Cisco firmware at this time, you could go in the settings and turn off WPS. And if you did, you could no longer use it, but the attack still works. Now that's just rude. It's still running and you can't use it. You're still vulnerable though. That's what they call turning it off. Well, you know, this is why you really need ethical hackers, because most products have just horrible mistakes and you'll never find them unless somebody's actually testing them. Yeah.
Why do they still include this?
Well, it is a convenience for most people. So it's still there. Most people, they'd rather do this. It's still there, even though it has a weakness. Most people, in fact, like I say, in practice, it's not a real vulnerability for most devices because they'll just crash as soon as you run the attack. So it's kind of nuts. You know, I think the actual amount of money stolen with this attack is probably pretty small because, in fact, you can't usually do it. This is true. Like, there's a nice chart that came out I saw last week. A guy made a page about how much actual damage have security vulnerabilities done. And like out of 20 of them, only 4 of them have actually been used to actually steal any real money. Like HTTPS has been through many revisions because of mathematical attacks, but none of them are practical enough to actually do in the real world. They prove that in principle it's not safe and everybody changes it, but in practice they're so annoying that it's a whole lot easier to just find somebody with a default password and steal their money. It's like, you know, I used to have a club you'd put on your car, and anybody who knows about cars said, what's wrong with you? You can just undo a bolt and get that off of there, but the car next to me doesn't have one. So they'll steal that car and not mine. So, you know, in the same spirit, a weak security measure is often enough as long as you're not a high-value target. They'll just go steal somebody else's stuff. That's an old joke, right? A guy's running away from a tiger, and he says, why are you running? We'll never outrun the tiger. And he says, I only have to outrun you. So anyway, so war driving and all the, you can just drive around and find the wireless networks. And we used to do this every semester to map the security of San Francisco. We gave it up a few years ago because here's the results. Year after year, when we started war driving in 2008, 50% of the networks were web and 21% were completely unencrypted. And that was how it all started. Originally, people would find the unencrypted networks and use them to access the internet. Before the time when there were cell phones and smartphones and cellular modems, it was actually hard to get internet service. So you'd find people who had an unencrypted network and just park near their house and use theirs. That's what a lot of people did. And so, but then what happened is now pretty much everybody's using WPA or WPA2. So it's kind of useless. There's no longer much security benefit to driving around. And it's not because people got smart and turned on the better protocols. It's just these devices got old and broke and they bought a newer device, and all the newer devices have WPA by default. And the 15% that's unencrypted is not necessarily stupid. Those are the public places like Starbucks that are unencrypted for a reason. And what it means, even though technically it's unencrypted, in fact, when you connect, you'll probably hit a paywall saying, now you have to put in your credit card number or something. So it's not using the wireless encryption standard, but it is probably secured by other means. So you just drive around, run software that scans the network. and it can just detect them. There's various softwares out there to do this, and it's not really worrying about the details anymore, because this there's a fun website that maps the whole world. Kismet is the Linux hacking tool that's really very powerful for hacking wireless networks, and it can also do war driving. But there's a fun website called Wiggle, which I think, and then of course there's the Wi-Fi Pineapple is the product you can buy and just use at hacking conventions such to man in the middle Wi-Fi and steal people's passwords and stuff.
It's like a rogue access point.
It's a rogue access point, and it automatically runs a sniffer and it replays things. You know, it just runs, it's sort of like a bunch of Corley tools running on a little Linux distribution to do a bunch of wireless attacks conveniently. And by the way, if you take one, about 5 years ago, a bunch of people went to DEF CON with these and left the default password on them. So a bunch of people had hacking tools that would just hack the hell out of it and put it in insulting swear words. You moron, why do you even come to DEF CON if you're this stupid? You're bringing on a device with a default password to DEF CON. If you go to DEF CON and connect to the wireless, there's like 100 rogue access points everywhere. It claims to be the airport, Washington, D.C., the Sheraton, 25 different copies of the DEF CON network. You know, using wireless at DEF CON is an adventure. Anyway, some people put up honeypots with fake wireless networks. I remember Kirk actually got me something where I run this thing called fake AP. There are various techniques to try to run fake wireless networks to distract attackers. That's all pretty lame, not terribly effective. Some people try to keep the wireless signal from leaving your building. So you could put special paint on the walls and screens on the windows and stuff. That might be a little more effective. Anyway.
Wireless printers.
Yeah, now there's wireless printers all over the place. And as we just found out this week, there's an incredible number of people with printers connected to the internet. So there's PewDiePie promoting printers. And there was a hack last week where he took millions of printers and created print pages advertising PewDiePie's YouTube channel. And so in response, there's a commercial service that just came up selling you advertising on other people's printers. And which is probably illegal. Probably just a scam, nobody knows. But in principle, you could totally do that. You could pay them money and they could print, and they say, we can hack at every printer in the world. We can run your message on everyone's printer. This will be great. I said, I don't think this will be so great, but anyway, it's out there. So if you do have a wireless network, then you should realize that the people coming in your wireless network are not really to be trusted, and you should put them in your DMZ. This is how you make networks. You have a internal network with your high value stuff like your credit card numbers and proprietary secrets, and you have untrusted network where you put your stuff that's directly connected to the internet like your web server, which is probably going to get hacked, and you don't put secrets on that. And then you have the internet out here, and your wireless network should be in the DMZ. You shouldn't really trust anybody in the wireless network without making them authenticate further to prove they're actually a company employee, because it's pretty easy to connect your wireless network without the proper permissions. And there's MAC address filtering, which is really pathetic. You can just go in the software and change your MAC address, of course. It wasn't even worth a project in this class at any time. You can just go into Device Manager and change it on a Windows machine. And you can do it with ifconfig on Linux. So I mean, MAC address filtering is really lame, because all you have to do is run Wireshark to sniff and find the MACs that are allowed, and then just change your MAC to one of them. MAC is red software. All right. So I got a few cahoots about that, and then we'll take a break, and I'll do just the first bit of the encryption chapter so you aren't totally ripped off, because encryption should be part of this. It's just that we ran out of time, and there'll be a whole class in encryption next time if you want it. But if you don't take that, we'll cover at least a little bit of it here.
I got 6 digits on it.
Yep. They have their algorithm, Lord knows. When I worked in claim settlement administration, we had this claim number which determined everything. And we didn't, to solve this problem, I learned when you count, you start at 100,001. And then count up. Now everything has the same number of digits. Kahoot didn't get this lesson. But it really mattered because we had a barcode, we had a database with a field. We really wanted it to always be the same length. So you don't start at 1 and count up. That will take you to bad places as you have the leading zeros. You start at 100,001, then count up. That's the way you actually make a structure. There's a lot of things like this I had to learn. In the world of business, you move from the world of math to a different set of problems. Anyway. Heard a funny noise. I thought there was a funny noise. Let's see, there's a chat coming in. Ah, Beck 2, good, thank you. I now know who Beck 2 is, all right? I can record it here. Okay, I got that. Okay. All right, I guess we're ready to go here. Okay, so which one of these sends passwords in plain text? Okay, looks like something is wrapping around incorrectly here. There we go. Come on, stop that. Anyway, all right. Anyway, all right, that's PAP, Password Authentication Protocol. All right, what's the digital certificate standard? All right, X509, that's it. All right, what was the security measure to patch web? Temporal key integrity protocol. Which one requires an authentication server? That's 8021X, which is the enterprise mode. All right, and which one is vulnerable to a simple brute force attack? That's Wi-Fi protected setup. Okay, good. And there's my winners. All right, so I'm going to stop the recording. I hopefully can remember to turn it on again after this, which I forgot last time. And we'll take a 10-minute break, pick up at 7:15.